In this problem, I'll put my terms in our standard form by moving the -2 cosine squared theta over to the left-hand side, getting 0 by itself, and I'll put the terms in descending order. Now, normally, at this point, I would factor in order to solve for cosine theta, and then finish solving for theta from there. But in this problem, this doesn't factor. So I'll have to use the quadratic formula. And the quadratic formula, if you remember, is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So instead of x, we really have cosine theta. That's what's being squared. So cosine theta equals -b, so that's a positive 4, plus or minus the square root of b squared, that's 16, minus 4 times a, which is 2, times c, which is 1, all over 2 times a, and that'll give me 4. So now I can simplify this, and I've got 4 plus or minus 16 minus 8, that gives me 8, so it's 4 plus or minus the square root of 8 over 4. Now I can simplify this. I could turn 8 into 2 square roots of 2, but to be honest, it doesn't matter because it's still not going to be something that I can say, oh, and of course, then theta must be this angle, whatever it is. So I'm going to need to put this into the calculator and take the inverse cosine in order to find what my angles are. So now I have theta is equal to cosine inverse of 4 plus the square root of 8 over 4, or theta equals cosine inverse 4 minus the square root of 8 over 4. So when I try the first one, notice that if we have 4 plus anything, it's going to make more than 4, divided by 4, this is a value that's greater than 1, and we can't take the cosine inverse of something greater than 1. Cosine can't be more than 1. So this gives me an error. So I'm just going to say no. No answer here. And we just scrap it and move on. So now I have cosine inverse of the quantity 4 minus the square root of 8 over 4. And when you're putting this into the calculator, again, just be very careful. You're going to have to type in, if you're going to type it in all at once, another set of parentheses. It's easy in the heat of the moment to forget about this. And your calculator may open up a parenthesis for the radical, so you need to close that, and then another close. And let's see, how am I doing on parentheses now? And now I'm going to divide by 4, and then I'm going to close. And this gives me 72.9 degrees. Doesn't say how to round, so I'm going to round to the 73 degrees. It's awfully close to that. So 73 degrees is my solution for this. And where else is the cosine going to be positive? And that's in quadrant 4. So I have 73 degrees in quadrant 1. So in quadrant 4, this angle, I can just take 360 minus 73, and my other solution would then be 287 degrees. And so that is my final answer there. Now in this problem, I have 2 cosine squared theta plus sine theta equals 1. And in the previous problems I've done, I always had, well, I shouldn't say always, but generally I had the same trig function to work with when it was something that looked like it was going to factor, like a quadratic. So what I need to do is get agreement, and what I can do to do that is change cosine squared into 1 minus sine squared. theta. And now I'll distribute the 2, and I'm going to take the 1 and subtract that from both sides at the same time. So I have 2 minus 2 sine squared theta plus sine theta minus 1 equals 0. And now let's get these straightened out and combine like terms. And now I can merely multiply both sides by -1, and that'll turn my leading coefficient positive, which is the one I worry about the most. All right, so now I'm ready to factor, and this factors nicely. This is 2 sine theta and sine theta. And we want this to turn out to be a negative sine theta in the middle. So it's 2 sine theta plus 1 times sine theta minus 1 equals 0. And now I can find my solutions. And here I have 2 sine theta plus 1 equals 0, which means that sine theta equals a negative 1/2. And sine theta minus 1 equals 0 means that sine theta equals a positive 1. So where is the sine function negative? It's negative in quadrants 3 and 4. So my quadrant 3 angle, and we're in degrees now, so that would be 210 degrees. And then in quadrant 4, that would be 330 degrees. And then sine theta is equal to 1 at 90 degrees. And that's it. So 3 solutions for that one: 90 degrees, 210, and 330. And that's my final answer.